We're going to be including a value of the items in the equations. We've been doing word problems for a while, and they're giving you little teeny steps here and there to be able to solve these equations. We're doing 5.8, and now we're going to do mostly money today with this, mostly money. So they've given you some steps. If you look in your book, they give you these steps, and they're going to tell you, use the 5 steps, and it tells you in the equation. And your steps, you're going to, obviously, you're going to read the problem. After you read the problem, this is what you're going to do. You're going to label and represent the unknowns. We've been doing that all along. Make x or some variable for one of them, and then add or subtract or multiply or something to that x for the next values. Number 2, you're going to set up an equation including the dollar values. This is the brand new one for today, is number 2. We are going to be setting up values. So if you had quarters, they're worth 25 cents. Or if you had nickels, they're worth 5 cents, and so forth. So you're going to be adding values to these. Sometimes we add values with the total amounts and so forth. Okay? Then you're going to simplify and solve your equation. We've been doing that all along. Then you're going to have to, depending on what they ask for, you might have to substitute back in to find your other values, and you have been doing that. Another thing that some of you forget to do is to check that it actually makes sense when you're done, that you actually found the right answers. Let's do some examples.
I would never do that.
I'm sure you wouldn't, Zeb, because you do everything perfect.
Yeah.
All right, let's do let's do the one together, and it has to do with money. Okay? There are times when you need to include the value of the money in the equation. So here is a problem. Here we go. Esther had twice as many quarters as dimes in her pocket, totaling $4.20. How many dimes and quarters does Esther have? So if we go by the very first sentence, she has twice as many quarters as dimes. Which one should we make the variable? We should make dimes the variable. So if I go with this and call this D, then this will be how much? 2D. Are you with me so far? And the dimes and the quarters, we don't know how many total dimes and quarters we have, but we know the total amount of money that we have. So
3x.
Oh, right. So we know, I'm going to just write a little equation here. The dimes plus the quarters equal $4.20. How much is the value of a dime?
10 cents.
10 cents. And what about the value of a quarter?
25.
25 cents. And this is $4.20. How many cents is that total?
420.
420 cents. So if I'm going to represent this as being 10 cents and this is 25 cents, I'm going to have that be 420, so that we're all talking about we're talking about cents. All right, so this is what we're going to do. This is the new part for you today. I need you to pay close attention, okay? We said that the dimes was going to be D, but if this is value over here, we have to have the value of 10 is the value, and this is how many dimes we have. 25 is the value, and we have twice as many dimes. We're representing that as the quarters. Excuse me, 2D. This is the equation we're going to solve. I want to stop here and make sure I answer questions, because this is the new stuff.
How do you how do you figure out how many dimes and quarters there are?
We're going to solve that equation from there. Do you understand where I got the D? Whoops. The D and the 2D up here?
Yeah, I understand that.
Do you understand how I plugged it into here? Okay, good. That's the part I want to make sure you know how to do that. I'm going to help you move forward in a minute. But I want to make sure everyone understands that we had to do, if this is total dollars, or total cents in this case, I have to have cents in my equation on this side to make it equal. Are there any questions about that part?
No.
Okay, so what we're going to do is this is going to become 10D right here. This is going to be plus 25 and 2 becomes 50D.
Scary.
Yes.
So do you just, for the number before the letter, is that just like saying how many cents it's worth or what?
Yes, that's exactly right. This is the value or the worth. So dimes were worth 10 cents. So we put a 10 with the D because there was 10 cents times the number of dimes. And it was 25 cents times the number of quarters.
Okay.
Okay? Good question. Other questions?
I had the answer.
Okay. We have a 10D and a 50D for a total of how much?
60.
60D equals 420. That's a 0, by the way.
Dimes and 14 quarters.
I'm going to do 60 divided by here, 60. Those zeros will cancel, and I'll have 7 dimes. Don't just write D equals 7. I need to know what that actually represents. How do I find out the quarters?
Multiply it by 2.
Because, that's exactly right, because up here, we said we had twice as many dimes. So we're going to multiply that by 2, and that would be quarters equals 14. And we're going to put the value, the units with it, quarters. And there is our answer. I would like to do another example because these are harder, I think. The word problem ones are a little harder. I want to make sure I did this right. I'm checking something. Yes. All right. Now, one other thing they need to check. Does 7 dimes and 14 quarters actually make $4.25? So if we took 10 times 7 and 25 times 14, would we get 420? Can somebody please check that? The person who's checked it and they verified that it's true. Just because one person checks it doesn't mean it's true, though.
Well, if it's ACED, then it does.
I would be more likely to trust it if it was at least 2 people. Kind of do the biblical model. 2 or more witnesses.
Multiply 70 times the number of quarters.
Yes, we're going to take 10 times 7 and 25 times 14 and add those numbers together. I hope we get 420 out of that. It's verifying it.
I got it.
You did get it, Ben? Okay. All right. I trust now we have 2 people. All right, let's do another one. We're going to do some more money. This one's got a little bit more into it. I've given you a little hint, though. We've got Carol's Cuisine Catering her service served 185 meals one evening, having total receipts of $1,935. If she charged $15 per plate for adults and $9 for children, she must not have kept track of how many she had, and she must want to know how many plates of adults and children she had, and she needs to figure out that. They didn't tell us how many, but they told us the total 185. So if I tell you that X is the number of adults, what equation can we put for the number of children? Oh, the total is 185. Just pretend that you knew there were 10 children. No, adults, which was very unlikely. How would you calculate the number of children if you knew there were a total of 185? What would you do to figure out the children?
You multiply.
Children,
How many
total up to 185.
Okay, how many dollars the children?
No,
want?
just people,
Or-
total. How many people
that
total?
is 185 minus 10.
Okay, so it'd be 185 minus 10. I know the adults are X. How do I figure? I need you to start thinking in algebra. What equation am I putting right there? If I know there's a total of 185 people.
It'd be 18 people, wouldn't it?
Just a second, Zeb. I've got a letter X here. I want it in terms of X. I want an X here.
X equals.
No, I'm sorry. I don't think you understand my question. I have 185 total people. You ready?
Uh-huh.
If I had 10 adults, how many children would I have? Okay, that's why I'm asking. Forget this problem up here for a minute, except for the 185 people. If I had 10 people, 10 adults, and there's a total of 185 people, how many children are there? How do I figure that out?
175?
Yes. Good job. I just take 185 minus the 10, right? What if I had 100 people? No, 100
Be 85.
adults.
85.
How many children would there be?
85.
85?
Yes, because I take 185 minus the 100. Okay, so then let me get my eraser up here. Now, what if I have X number of people? Adults. X number of adults. How many children will I have?
You have 185 minus X.
185 minus X. You guys with me so far? I need you to start thinking like algebra. We know that the cost of the children, or the adults will do this, the cost of the adults plus the cost of the children, she got a total of $35. Are you with me so far?
Yep.
How are we doing, Zach? Are you with me so far?
Yes.
All right. How do we figure out how much how much did it cost for her? I mean, how much did she make on every adult?
$15.
$15 times the number of adults. How much did she make on the children?
9 times 185 minus X.
Very good. Equals a total of 1935. This is why we learned how to do the distributive property a long time ago, so we could do problems like this. I'm going to let you work on that one while I work on it and see if we can get the right answer together. And I don't know what 9 times 135 is. I have to do that. 185. I didn't memorize my 185 times tables.
I did.
You did? Oh, good job, Zach.
You're right.
I figured Zeb did.
I might be kind of smart, but I ain't that smart.
Someone let me know when they're done.
How'd you get 6X?
I have the 15x minus the 9x.
I'm a little confused.
You're not the only one.
Do you have all these numbers that's similar to mine,
I'm done.
Zach?
I'm just trying to figure out like how to set it up as an equation. Like once you get everything, it's probably pretty easy to solve. I'm still trying to figure out how you got what you got.
Okay, all right, that's what I want to know. Fantastic. So have you finished solving this equation though? Or you just been trying to work on how I got everything?
I wrote down stuff and then I solved something and then I looked up and yours was really different.
Okay.
And I don't know what it was, so.
Okay, so up here, let's start at the top then. I changed my color to red. Do you know where I got these things?
Yes.
Okay. Do you know where I got this sentence? The cost of the adults plus the cost of the adults is $19.35.
Yes.
Okay. So the cost of the adults is $15 times the number of adults. Do you see how I got 15x? Because it's $15 for the adults. You have a question about that, Zach?
No.
No. Okay. So you understand that part. Okay. Sorry. Because this is a total amount. So the total amount for the adults was 15 times the number of adults. This one is going to be $9 because the $9 was for the children times the number of children. And we said the number of children was 180 minus X. So then the total here, then we have the 1935. So we just brought that down. Is there questions about what I have in red right there?
So X is the amount of plates.
For the
right?
adults. For the adults, yes.
Okay.
Okay? So, then we just started solving. I brought down the 15x from up there. I did the distributive property for these. And then I solved it after that. So are you working on solving that one now, Zach?
Yes, I'm working on it.
Okay, good. Okay, good. And Ashton, how are you doing? All right, I have that 1,665. I have that plus 6x equals 1935. Are you at that point, Zach, at all?
Yes, I'm past that.
Okay. And then do you have the 6x equals 270?
Yes.
All right. All right. What did you get for x, Zach?
45.
All right. Ben, is that what you got?
Yes, ma'am, that's what I got.
All right. Now the question, we got to go back and see what we've solved the question. It says how many of each do they need to serve? So we have adults here. Excuse me. Yeah, this is adults. So 45 adults. How do we find children?
It's 140 children.
How did you decide that?
I subtracted 185, 45 from 185.
Yes. So we're going to come over there and take 185 minus 45. And you said that makes what?
140.
140 children.
So I was correct.
So you got it. Good job. Good job. All right. Okay, so these are harder. These are harder. These are harder, so we need to be putting in the values of the dollars in these.
What are harder?
All right, let's try some. I think we're going to be working on the ones from your textbook now. I need to get a consensus here. Do you want to try to set this one up by yourself, or do you want me to help you with it?
Help. Limits.
Maybe just not do it.
That wasn't one of the
I like
options,
Zeb's
Zeb.
option.
That wasn't one of the options. Don't throw things that make such All right. I'll at least get you started on the variables, but then you can set the equations up. How about that? Susie operates a catering service. One evening, she served 96 people, but she didn't count the number of children or adults she served. She charged $12 for adults and $8 for children and made a total of $916. How many children did Susie serve? Now, we don't have to find both children and adults this time, so we probably should make our X value children. How many adults did she serve then? With the equation.
96 minus X.
Does anybody agree with Zach?
I agree.
Okay. That's correct. 96 minus X. The concept that we need to do is that children, or actually the money from the children, plus the money from the adults, totaled how much?
$9.16. Sorry, I'm struggling with
Yes.
math.
So right now, I want all of you to write an equation right here. Don't try to solve it yet, but I want you to try to make an equation and tell me when you're finished so that I can help you.
Done.
I got one person who's done to write the equation. Do you have an equation, Asa?
Wait, not solving it. Just
Right,
setting it up,
exactly.
right?
Just setting it up. Don't solve it. I need to know who set it up. I've got two people who've set it up. That was Ben and Asa. Who
I
else?
set it up.
And then Zach's done setting it up.
I'm still trying to figure it out.
All right, so Ashton, you're going to work with me. Here we go. Let's try together. How many children do we have, Ashton?
I have adults equal 96 minus x, and children equal x.
That's right.
That
So
means x plus 96 minus x equals 916.
almost, because this is the dollar amount. So we have to take the dollar amount of 8 times the number of children, because we've got dollars over here. Since there's dollars over here, we have to put the dollars with it. Does that make sense?
Yes, ma'am.
So we've got $8 times the number of children. That'll be our total money for the children. What do you think it's going to be for adults, Ashton?
It's 12
Good.
times 96 minus 8x.
Over here, the number of adults is just 96 minus x, and we don't have to plug in the x. We just go 96, not next. Just a second, let me go back. 96 minus x.
I'm done.
Now we just need to solve this equation. Now we're going to solve it. Let me know when you're done solving. I believe I've got one person done solving it.
I'm done solving it.
Okay. Do you have the same numbers so far that I have? I haven't finished, but have I done everything right so far?
Yes.
Okay.
Miss Carrie, where did you get the 1152?
Good question. I love it when you ask that. What I did is I'm going to change colors here in red. I took this 12 times 96 because I did the distributed property.
Uh,
All right. Here we go. I've got this up here. I did the distributed property right here. I combined my 8 and my 12, and I noticed a negative. And when I got a negative, I was like, oh no, we might have done something wrong. Because if I divide by a negative, and if this side over here is not negative, I will get a negative answer, and there's no way we're going to have negative children. So I was a little nervous that we had done something wrong, but then when I realized that when I subtract this over here, I also get a negative, so everything turned out okay. So I have a negative 4x and a negative 236, and I divide those negatives and negatives, and what did you guys get?
I got 59 children and 37 adults.
Okay, so
that's
I
what I
got...
got.
If you don't need adults.
Now the cool thing is you went above and beyond, Zach. That's wonderful, but I want you to look at the question. It said how many children, and they don't really care about adults. That doesn't mean you can't find it. But you need to realize this is not as much important now as if you take a standardized test, and if they have multiple choice, and what did you say adults was, Zach?
I said 37 adults.
If they would have had a multiple choice for like A and B, and you picked the one for 37, you'd have been wrong because you answered the question wrong. Now, right now, you're actually getting, in a sense, extra credit because you did extra, but sometimes, depending on who you're answering the question for, you could get it wrong.
Okay.
That's not a problem right now. The reason we picked X right here was because it's what the question is answering, and we didn't have to go back and substitute in. You could have picked X for the adults, and children would have been the 96 minus X. And then when you substituted in, you'd have substituted in the backwards way and had a different answer, but then you have to go back and find it. So that's why we were nice for you and picked the X for the children, because it would be easier when you're done. Please ask me some questions if you don't know how I got 59. All right, the key to this step right here is more valuable than it ever has been. And then you need to plug in the values or the the money values in for them when you're multiplying us because you had money values at the end. All right, you have learned how to include the value or the money value of items into your equation, which is brand new. You do the equation stuff that's similar as you've done before, but now you're just going to add that money stuff in. Are there any questions for me? All right, we're done.